Good morning, students. Yesterday we have solved examples of practice set 4.1. Today we are going to solve examples of practice set 4.2. First we'll solve the solved examples of textbook, Maths 1 textbook page number 62. First example is, this is solved example 4 upon 9 and 7 upon 8. We have to compare these pairs. Okay, we have learned about the comparison of ratio rule. Now what we'll do? We'll do cross multiplication of it. So it will be 4 into 8 and 7 into 9. Now 4 8s are 32 and 7 9s are 63. Now which number is bigger? 63. So we'll mark it like this. Okay, now we'll write down the given pair. That is 4 upon 9 and 7 upon 8. We'll mark same here. Okay, in this way we have to compare the ratios. We'll take next example. That is also solved example of your textbook. Under root 13 upon under root 8 under root 7 upon under root 5. Okay, here also we'll do cross multiplication. Under root 13 into under root 5 and under root 7 into under root 8. Now 13 5s are 65 and 7 8s are 56. Okay, now we'll compare these numbers 65 and 56. Which one is greater number? 65. We'll mark like this. Again here we'll write the given pairs, that is under root 13 upon under root 8 and under root 7 upon under root 5. We'll mark same here. Okay. In this way we have to compare the given pairs of ratios. Which one is smaller and which one is greater, that we have to decide by its cross multiplication. We'll take third example, solved example of our textbook. If A and B are integers and A is smaller than B and B is greater than 1, then compare A minus 1 upon B minus 1 and A plus 1 and B plus 1. Now again two pairs are given, A minus 1 upon B minus 1 and A plus 1 upon B plus 1. That we have to compare. Now what is said that A is smaller than B? It means A minus 1 is also smaller than B minus 1. Okay, now we'll do subtraction of the given pair. That is A minus 1 upon B minus 1 minus A plus 1 upon B plus 1. We'll simplify this. Here we'll take A minus 1, we'll multiply with B plus 1 minus A plus 1 into B minus 1 upon B minus 1 and B plus 1. Now we'll multiply these brackets. So it becomes AB minus B plus A minus 1 minus, we'll multiply A plus 1 into B minus 1. That is AB plus B minus A minus 1 upon B minus 1 into B plus 1 becomes B square minus 1. Okay, now we'll remove these brackets. We'll simplify this. AB minus B plus A minus 1. Now this we'll remove this bracket. Minus AB minus this plus B becomes minus B. Minus A becomes minus becomes plus. Plus A plus this one also becomes plus upon B square minus 1. Now this plus AB minus AB cancel, plus 1 minus 1 plus 1 cancel. Now here 2 plus A's are there, it becomes 2A minus B and minus B becomes minus 2B. Here B square minus 1 as it. We'll take 2 common here, A minus B upon B square minus 1. This is marked as equation number 1. Now A is smaller than B, therefore A minus B is also is smaller than 0. Means, okay, also B square minus 1 is greater than 0. Why? Because B is greater than 1. Therefore, whatever this term we have got, that is 2 into A minus B upon B square minus 1, that is smaller than 0. Okay, this is marked as second equation we have got. Okay, so from this what we have arrived, this value is of A minus 1 upon B minus 1 plus A plus 1 upon B plus 1. Okay, it means A minus 1 upon B minus 1 minus A plus 1 upon B plus 1. That is also smaller than 0. So we have our terms are A minus 1 upon B minus 1 and A plus 1 upon B plus 1. So here the first term is smaller than the second. We'll take next example, that is the fourth example. If A s to B is equal to 2s to 1 and B s to C is 4s to 1, then find the value of A raised to 4 upon 32B square C square whole bracket cube. Now what is given? A s to B, that is 2s to 1, means A upon B, that is equal to 2 upon 1. This we can simplify as A is equal to this B will take towards right hand side, so it multiplies, that is A is equal to 2B. Again B s to C is given, that is 4s to 1. We'll write B upon C, that is equal to 4 upon 1. Again here we'll simplify, B is equal to this C towards right hand side multiplies, so 4C. Now we'll put value of B here. We have got value of A as 2B. So we'll put value of B here. So it becomes A is equal to 2B. So it becomes 2 into 4C. So it becomes 8C. Now we have got value of A as 8C. And we have got value of B as 4C. Now we'll put these values into the given equation. What is given? A raised to 4 upon 32 B square C square whole bracket cube. We'll put this value. Value of A is 8C raised to 4 upon 32 into B square, that is 4C square. 4 square and c square into c square as it is, the whole cube. Now we'll simplify this. 8 into 8 into 8 into 8 into c raised to 4 upon 32 into 4 square is 16 into c square c square. Now we'll simplify this. This c raised to 4 and c square gets cancelled. 8 ones are 8, 8 twos are 16, 8 ones are 8, 8 fours are 32, 4 twos are 8 here. So we'll cancel 8, 1 8 from numerator. Now what is remaining? That is 8 cube. And the value of 8 cube is 512. This is the value of this given bracket. Okay, now we'll solve examples given in practice set 4.2. Question number 1. Using the property A upon B is equal to A into K upon B into K, fill in the blank substituting proper numbers in the following. Now first example is 5 upon 7 is equal to dash upon 28, 35 upon fill in the blank, dash upon 3.5. Now we have to fill these blank. Now 5 upon 7 is given. We'll take this first term, dash upon 28. Now we split this number. That is, we have to split with 7. So it becomes 7 fours are 28. So here also we'll multiply 5 with 4. So that is 28 and 20. 5 fours are 20. 20 upon 28 means this fill in the blank is 20. Okay, in the same way we have to do for next 35 upon dash. We have to find factors with 5. So it becomes 7 fives are 35. So here also we'll multiply 7 with 7. So it becomes 7 fives are 35 and 7 sevens are 49. So our fill in the blank is 49. Third one, fill in the blank upon 3.5. Again, this 3.5 is half of 7. Okay, so here also we'll take half of 5. It becomes 2.5. So this fill in the blank is 2.5. Finally, you have to write this whole sentence towards downside. That will be your final answer. Just go through this. Okay, we'll take second example of question number 2. 9 upon 14 is equal to 4.5 upon fill in the blank is equal to fill in the blank upon 42 is equal to fill in the blank upon 3.5. Now it's 9 upon 14. First is 4.5 upon fill in the blank. Now this 4.5 is half of the 9. So here also we'll do half of the 14. So it becomes half of the 14 is 7. This is our answer. Next is fill in the blank upon 42. Now we have to split with 14. 14 threes are 14 threes are 42. So we'll multiply 9 with 3. 9 threes are 27. This is our next fill in the blank. And for third example, fill in the blank upon 3.5. This 3.5 is 1/4 of 14. So 14 into 1 by 4 will be 3.5. So we'll do with same with 9 also. 9 into 1 by 4. So that is that becomes 2.25. This is our answer. Just go through the solution. We'll take question number 2 of practice set 4.2. The ratio of radius to circumference of a circle. Now what is the radius of the circle? That is small r. Okay, and circumference of a circle is 2 pi r. Now to take ratio of this, that is radius upon circumference. So we'll write r upon 2 pi r. This r gets cancelled. So 1 remains at numerator and 2 pi at denominator. So this is the ratio 1:2 2 pi. Second example, the ratio of circumference of circle with radius r to its area. Now circumference of a circle is 2 pi r. Okay, and the area of the circle is pi r square. Now we have to take this ratio, circumference to area. Area of a circle, that is 2 pi r upon pi r square. This pi gets cancelled. 1 r from here also gets cancelled. We'll write r into r. So what is remaining? 2 upon r. So the ratio will be 2:r. Okay, we'll take third. What is given? The diagonal, the ratio of diagonal of a square to its side if the length of side is 7 centimeters. Now what is the formula to find out diagonal of a square? That is under root 2 into side. Side is given. That is 7 centimeters. So it becomes 7 under root 2 centimeters. Okay. And length of side is 7 centimeters. Now we have to find out the ratio of diagonal of a square to its side. So we'll write diagonal to its side. Diagonal is 7 under root 2 and side is 7. This 7 gets cancelled. So what is remaining? Under root 2 upon 1. So the ratio will be under root 2 as to 1. This is our answer. Just go through these solutions. We'll take fourth example of question number 2. The lengths of sides of a rectangle are 5 centimeter and 3.5 centimeter. Find the ratio of its perimeter to area. Now what is the formula to find out perimeter of rectangle? Length and breadth are given. So perimeter of rectangle is equal to 2 into length plus breadth. That is 2 into 5 plus 3.5. 5 and 3.5 is given. So 2 into 8.5. It becomes 17 centimeters. Now we have to find out area of a rectangle. What is the formula to find out area of a rectangle? That is length into breadth. What is length? It's 5. Breadth is 3.5. So it becomes 17.5. Okay. Now what is that? The ratio of perimeter to the area of a rectangle we have to find out. That is perimeter to area. That is 17 upon 17.5. But here there is one correction in the statement. Find the ratio of the perimeter to the numerical value of the area of the rectangle. So what we'll do? We'll multiply it with 2. 17 into 2 upon 17.5 into 2. So it becomes 34 upon 35. This is the ratio we have got, 34 as to 35. We'll take question number 3 of practice set 4.2. First, compare the following pairs of ratios. Under root 5 upon 3 and 3 upon under root 7. We'll do cross multiplication here. Under root 5 into under root 7 and 3 into 3. 7 5s are 35. 3 3s are 9. We'll take into the under root so that we can find out which number is bigger. We'll write 9 as under root 9 square. That is 81. Here also we'll remove the under root, so it becomes 35. Now which number is bigger? 81. So we'll mark like this. We'll write down the given ratios, given pairs, that is under root 5 upon 3 and 3 upon under root 7. We'll mark same here. In this way we can compare the given ratio. Second example, 3 under root 5 upon 5 under root 7 and under root 63 upon under root 125. First we'll simplify under root 63 and under root 125. It becomes 9 sevens are 63. We'll write it as 9 under root 9 into under root 7. That is, this under root 9 becomes 3 under root 7 as it is. Under root 125, that is 25 5. Again here under root 25, under root 5. Under root 25 becomes 5, under root 5 as it is. Okay, now we have got 3 under root 7, 5 under root 5. We'll write these terms again. 3 under root 5 upon 5 under root 7 and under root 63 upon under root 125 we have simplified as 3 under root 7 upon 5 under root 5. Now 3 upon 5, 3 upon 5 is common here. Okay. Now what we have to do? We have to compare these. Under root 5 upon under root 7 and under root 7 upon under root 5. So under root 5 upon under root 7 and under root 7 upon under root 5. If we'll square these numbers, then what will happen? 5 upon 7 and 7 upon 5. Now we have to compare these numbers easily. Okay, so which number is bigger? 7 upon 5. So we'll mark it like this. Okay, same we have to write down the pairs again and we have to mark like this. That is, our terms are 3 under root 5 upon 5 under root 7 and under root 63 upon under root 125. We mark same. Okay, we'll take third example of question number 3. Third is 5 upon 18 and 17 upon 121. Again, we'll do cross multiplication here. That is 5 into 121 and 18 into 17. 5 into 121 is 605 and 18 into 17 is 306. Now we can easily compare which number is bigger. Okay. So again we have to write down the given terms 5 upon 18 and 17 upon 121. And we have to mark same. the fourth example. Under root 80 upon under root 48 and under root 45 upon under root 27. We'll simplify these terms. Under root 80 upon under root 48. That is 16 5s are 80 and 16 3s are 48. So here 16 gets cancelled. So what is remaining? Under root 5 and under root 3. Then under root 45 upon under root 27 will simplify. 9 5s are 45 and 9 3s are 27. Here again 9 gets cancelled. So what is remaining? Under root 5 upon under root 3. Both these terms are equal. Means whatever the pair is given, that is equal. Under root 80 upon under root 48 and under root 45 upon under root 27. That will be equal. We'll take fifth example of question number 3. 9.2 upon 5.1 and 3.4 upon 7.1. We'll do cross multiplication here. 9.2 into 7.1 and 3.4 into 5.1. This becomes 65.32 and 3.4 into 5.1 becomes 17.34. Now we can compare. 65.32 is greater number. So we'll mark like this. We'll write down the given pairs, that is 9.2 upon 5.1 and 3.4 upon 7.1. So this is great. First term is greater than 2. We'll take first example of next question, that is question number 4. ABCD is a parallelogram. The ratio of angle B and A and angle B is B of this parallelogram is 5:4. Find the measure of angle B. Now what is given? Angle A and angle B is 5:4. Now we'll take common multiple of the ratio, that is x. So it becomes 5x degree as to 4x degree. Okay, we'll add the angle A and angle B because they are interior angles of parallelogram. So angle A and angle B, their measure is 180 degree. We'll put the values of angle A and angle B, that is ratio 5x degree plus 4x degree is equal to 180 degree. We'll add this 5 and 4, it becomes 9x is equal to 180. We take 9 towards right hand side, so x is equal to 180 upon 9. We simplify this. 9 1s are 9, 9 2s are 18, so 0. X is equal to 20. Now we have got value of x as 20. We'll put these values here. We have considered as common multiple as x. So angle A is 5x degree and angle B is 4x degree. We'll put value of x and we'll get value of angle Here we have to find out measure of angle B. So we'll put here 4 into 20. It becomes 80. So we have got value of measure of angle B, that is 80 degree. Ratio of angles is given. ABCD is parallelogram. AB are the interior angles. Their measure will be 180 degree. We have considered common multiple as x. We have added the ratio and we have got value of x. We have put the value of x and we have got value of, that is measure of angle B. We'll take second example of question number 4. The ratio of present ages of Albert and Salim is 5:9. Find years, hence ratio of their ages will be 3:5. Find their present ages. Now ratio of present ages is given. Albert and Salim as 5:9. We'll take actual of their ratio 5x and 9x. Okay. Now what is said? 5 years, hence ratio of their ages will be 3:5. So what we'll do? We'll add 5. So the Albert's age will be 5x plus 5 and Salim's age will be 9x plus 5. Okay. Now the ages will be 3:5. Now what we will get 5x plus 5 upon 9x plus 5. Its ratio will be 3:5. That is 3 upon 5. Now we'll do cross multiplication here. 5 into 5x plus 5. 3 into 9x plus 5. That is becomes 25x plus 25. 9 3s are 27x plus 15. Now we'll take this 27 towards left hand side. So 25x minus 27x and 15. This will take 25 takes towards right hand side. So 15 minus 25. 25x minus 27x will be minus 2x. 15 minus 25 will be minus 10. Here this minus 2 is in multiplication form. Will take towards right hand side, so it divides. X is equal to minus 10 upon minus 2. We'll simplify this. Minus minus becomes plus. 2 1s are 2, 2 5s are 10. Okay. Now we have got value of x. We have to find out their present ages. So 5x is equal to 5 into 5 and 9x of Salim says, that is 9 into 5. 5 5s are 25 and 9 5s are 45. This is Albert's age, 25 years, and Salim's age is 45. Okay, in this way, we have to find out the present ages of the person. Just go through the solution. Okay, we have completed with practice set 4.2. The sub-question 3, 4 and 5 of question number 4 is reduced from your syllabus. Question number 5, 6, 7 are also reduced from your syllabus. Okay. Now we'll move towards operations on equal ratios. If ABCD are positive integers, then first operation is invertendo. That is, if C upon D, then B upon A is also equal to D upon C. We'll take one example. If A upon B, that is 5 upon 3, A is 5 and B 3 is B. Here 15 upon 9. That is value of C we have taken as 15 and D as 9. Then we have to write down as B upon A, that is 3 upon 5 is equal to D upon C, that is 9 upon 15. We can simplify this. 3 3s are 9 and 3 5s are 15. So you can see here 3 upon 5 is equal to 3 upon 5. Second, alternando. If A upon B is equal to C upon D, then A upon C is also equal to B upon D. That is 5 upon 3 is equal to 15 upon 9. That is 5 upon 15 is equal to 3 upon 9. Can simplify this. 3 1s are 3, 3 3s are 9. 5 1s are 5, 5 3s are 15. That is 1 upon 3 is equal to 1 upon 3. Okay. Third is componendo. If A upon B is equal to C upon D, then A plus B upon B is also equal to C plus D upon D. Here we are taking value of ABCD as 5 3 and 15 9. Now A plus B, we have to add 5 plus 3 upon 3, C plus D, 15 plus 9 upon 9. 5 plus 3 is 8 upon 3. 15 plus 9 is 24 upon 9. We can simplify this. 3 3s are 9 and 3 8s are 24. That means 8 upon 3 is equal to 8 upon 3. Just go through these 3 rules. Fourth is dividendo. If A upon B is equal to C upon D, then A minus B upon B is equal to C minus D upon D. Here 5 upon 3 and 15 upon 9. A minus B means 5 minus 3 upon 3, 15 minus 9 upon 9. 5 minus 3 is 2 upon 3, 15 minus 9 is 6 upon 9. 3 2s are 6 and 3 3s are 9. That is 2 upon 3 is equal to 2 upon 3. Fifth operation, componendo and dividendo together. Componendo we have added and dividendo we have subtracted. So we'll do both the operations here. A upon B is equal to C upon D. Then A plus B upon A minus B, that is equal to C plus D upon C minus D. Okay. Now we'll take value of A as 5, B as 3, C as 15, D as 9. We'll put these values 5 plus 3, 5 minus 3. 15 plus 9, 15 minus 9. 5 plus 3 is 8, 5 minus 3 is 2. 15 plus 9 is 24. 15 minus 9 is 6. Now we can simplify this. 2 ones are 2, 2 fours are 8. 6 ones are 6 and 6 fours are 24. What we have got? 4 upon 1 is equal to 4 upon 1. Just go through these operations. We have to solve examples given in 4.3 based on these operations. Okay, students, thank you so much.